Okay, our next set of questions we've just dealt with, working out equations of medians and things like that. It is the angle with the axis. We'll look at this type of question just now, okay? So let's start off with this question. It's a little two marker, okay? Determine the angle the line makes with the positive direction of the x-axis. The first thing you want to do is draw this out. Okay, draw this out. Okay, so there's my x-axis. There's my y-axis. Tell me why. And let's just draw a line. So I'm not sure just now, but I'll just draw a line. And so I'll say this is my line here. Okay? So if that's the line, then I am looking for this angle in here. That's the angle it's going to make with the positive direction of the x-axis. So yeah, the x is positive here, x is negative over there, y is positive here, y is negative. So it's this one, and it goes round. You measure the angle, and from here, from the axis, round that way. So if the line was going this way, we would want this angle in here. Okay. So let's get started then. That's what we think. So I'm saying this line is y is equal to negative root 3x plus 5 equals 0. Sorry, so that's a take away in there. So let's put it in the form y equals mx plus c so we can see what our gradient is. That's going to be our first step. So I'm going to say then that y is equal to root 3x take away 5, because I'm going to add root 3x to both sides, take away 5 to both sides. So I'm quite confident, there we go, my gradient m is equal to root 3, or in this case, root 3 over 1, because this is an exact value question. These two triangles are what you're going to use to solve that. Whenever you get an exact value type question, you want to draw out these two triangles. You want to draw out your 45-degree one, 45, 45, and that's a 1, 1, root 2. And then you want to draw out your 30, 60. And always remember that the 30s, the 3's go together, and then you got a 1 and a 2. So this m is equal to root 3 over 1. So what that's saying is that tan of an angle is equal to root 3 over 1, because tan theta equals m. Okay, tan theta is equal to m. Now tan, as we know, is OA, SOHCAHTOA. TOA. So this is my opposite and this is my adjacent. I'll go down to here and I'll say, right, root 3 is the opposite, 1's the adjacent. So which angle is adjacent to this one and opposite this one? Well, it's going to be 60 degrees. So I would then finish off by saying m is equal to, oh, not m actually, sorry. I'd actually finish off by saying theta is tan inverse root 3 over 1, which is equal to 60 degrees. If you had a calculator, this is what you would have done. It might not be one of these exact values, but we didn't need a calculator because the root 3 and the 1 appear on the table. Okay, so step 1, you were looking at rearranging, and step 2 is all about this equation and your exact values tables. So we know that this angle in here, we've just calculated that as 60 degrees. Let's go for a slightly trickier one. Now, this one's in radians. They've given us a diagram which is very helpful. Determine the equation of the line. So very similar, actually, very similar. A little kind of mix of what we've just done and what the last video is. So if we were doing the equation of a line, we're all about point, gradient, equation. We're looking at this line along here. So I know a point, I know negative 2, 0. That's good. Equation is going to be this. And I work out the gradient of this line. Well, to work out the gradient, I either need 2 points or some other information. So I have 2 points. So we're going to be using the tan theta is equal to m. This in here, vertically opposite angles, that is going to be pi over 3. Oops, pi over 3. I know this is 90 degrees, so I can work out this angle in here. Now what I'll do on the side, okay, I'll say that 2 pi is equal to 360, just to remind me. Pi is 180. Pi over 2 be 90. So I know in here I've got pi over 2. So I've got 90 degrees, and pi over 3 then is going to be 180 divided by 3, so it's going to be 60 degrees up there. So I've got 60 and 90, so this is going to be 30 degrees, which is going to be pi over 6. If I know in there, I've got pi over 6. Fantastic. So let's just double check that. Pi over 3, which is 60, that's good. Pi over 2 is 90, this is 30, 180 divided by 6, yeah, like that. So to work out the gradient, I'm going to say that m is tan theta. I know the angle, so it's going to be tan of pi over 6. That's going to give the gradient. And again, this goes back to our exact values. I'm just going to draw my triangles in. Say I've got, I'll just do this bit in degrees, 45 and 45, 1 root 2. Say I've got 60, 30, that's root 3, 1 and 2. So I'm looking for 30 degrees, 30 degrees, tan of. So there's 30 degrees here. So tan of 30 degrees, COA, opposite over adjacent. So that means that m is equal to 1 over root 3. Okay, so it's kind of the same as what we had last time. Instead of working out the angle, we're working out the side. Okay, so tan of this angle is the same as giving you tan of theta equals your opposite over adjacent, which is the same as m. I'll just write that in. Opposite over adjacent. So we've got our gradient, we've got our point, we can now work out the line. So it's going to be y, take away b, 0, 1 over root 3, x take away -2, so it's a plus. So I've got y is equal to 1 over root 3, x plus 2 over root 3. Or, if you wanted, you could maybe just write it a bit nicer. So I'm going to put a big or here. You could multiply everything through by root 3 and say that's the same as root 3y, which is equal to x plus 2. That's fine. But this is in the form y equals mx plus c. So, again, you're looking at the equation of a line. So you're doing point gradient equation, PGE. And here there was just a little bit of faffing about to work out the angle. So this angle in here, yeah, this angle here, which is the same as this angle in here, we can use that to work out the gradient with our little equation, m equals tan theta. If it's in the non-calc paper, be wary, you will have to remember your two exact value triangles. Fantastic. And our very last one, if I can squeeze it in time-wise, let's have a look. Minute and a half, oh, be quick. So a line makes an angle of 30 degrees with the positive direction of the x-axis. Okay, so that's going to look something like this, 30 degrees. Find the equation of the line perpendicular to that, which passes through the point 0, -4. Okay, so that line is perpendicular and it goes through the point 0, -4. Okay, so same again, point, gradient equation. So this time we know a point of 0, -4. Can I possibly work out the gradient of this line? Well, I can, because the gradient of this line is m equals tan theta. And I'll take 1 over and change the sign for that. I'll say gradient is m equals tan theta. So m is equal to tan of 30 degrees. And just to save me some time, I'll look at my triangles before, one I made earlier. So 30 degrees over here, opposite over adjacent is going to be another m equals 1 over root 3. Okay, tan of 30, opposite over adjacent. There's my 30, 1 over root 3. So that means that the perpendicular gradient is going to be -3. And then we're into the equation. Y plus 4, take away a negative, is negative root 3, x take away 0. So y plus 4, negative root 3x